Okay, let's unpack this. We are doing a deep dive, covering a stack of sources that span just 7 highly consequential days for Anthropic, December 28th, 2025 through January 4th, 2026.
Yeah, this wasn't a week for flashy new model announcements. This was a real pivot point.
It really was.
It marked the moment where high-end frontier AI moved from being, a voluntary, self-regulated safety project to a highly regulated mandatory utility. The velocity of change in that 1 week was just tectonic.
Absolutely. Our mission today is to cut through that holiday period to give you the high-value summary of that pivot. We're tracking 3 simultaneous pressures. First, the transition to a legally mandated compliance framework.
Right.
Second, the emergence of a frightening new security threat model that, frankly, shatters the traditional AI security perimeter.
A huge one.
And finally, the immediate, almost painful economic pressures forcing developers to completely refactor their pipelines.
And when you look at the documents from this tight window, you realize the industry's focus is fundamentally changing. It's no longer just about how intelligent the model is.
No.
It's about how efficient and, crucially, how secure the entire infrastructure around that model has to be to operate legally and effectively.
Let's start with governance then, because the turn of the year wasn't just symbolic, it was legally binding. Our sources confirmed the mandatory Frontier Compliance Framework was activated on January 1st, 2026. What exactly compelled this transition?
Well, this was a direct mandated response to California's Transparency and Frontier AI Act, SB 53, which became law on that very same day.
Okay.
For any frontier lab operating in California, this marks the official formal end of the era of pure self-regulation.
So they already had the Responsible Scaling Policy, the RSP. Why does this new one, the FCF, matter so much?
Because it completely transforms the stakes. I mean, the RSP was essentially a voluntary promise. The Frontier Compliance Framework, or FCF, makes these safety protocols a legally enforceable regime.
Legally enforceable.
Exactly. It immediately subjects their processes to state oversight, specifically concerning the risk of catastrophic harm. If a model exceeds certain predefined risk thresholds, they are legally compelled to report it.
That is a critical shift.
Mm-hmm.
It's moving from self-reporting when you feel like it to compelled reporting.
Right.
Can you elaborate on what the FCF actually demands transparency on?
The framework is extremely precise. It requires formalized assessment and mitigation strategies for 4 legally defined catastrophic risk vectors. These aren't abstract concepts from research papers anymore. They are codified threat areas Anthropic now must defend against.
Give us those 4 vectors, because they really do paint a picture of what policymakers are worried about.
Okay, so first, they must transparently manage the risk of cyber offenses. That's the AI's ability to autonomously develop or exploit sophisticated cyber tools. Second is CBRN threats: chemical, biological, radiological, and nuclear misuse potential. Third, they must prevent model sabotage and weight theft.
Protecting the core IP.
Exactly, and preventing adversarial changes to the system.
And the 4th one, the one that always sounds a little like science fiction, loss of control. What does that actually mean in a policy context?
It means managing the risk of a model bypassing its core alignment instructions, or exhibiting deceptive behavior that might go undetected during testing. The FCF requires documentation on how they test for the system hiding its true capabilities.
Wow.
And if a model crosses a certain risk threshold, which is measured in specific performance metrics defined in the FCF, Anthropic is legally obligated to immediately report their findings and mitigation plan to the state. That's accountability with teeth.
So 2026 kicks off with this mandatory risk report card. But that accountability is, well, it's useless if the system itself has novel security flaws that compliance hasn't even factored in yet.
Which brings us to a major discovery that dropped just before that deadline.
Right. Indirect prompt injection identified in MCP Claude Code on December 28, 2025.
This is maybe the most significant security finding of the week because it fundamentally changes the security boundary for autonomous AI agents, especially those using Anthropic's Model Context Protocol, or MCP.
We need to slow down here and define this, because when most developers hear prompt injection, they think about trying to trick the model in the chat box.
Yeah, a direct attack.
So what is indirect prompt injection, and why is it so much worse?
Think of it as a digital Trojan horse. The old type of injection was a direct attack from you, the user. This new indirect attack is an instruction hidden in a file, a website, a data source that the AI agent is told to read.
A source the developer trusts.
A source the developer trusts, precisely. You're working with Claude Code and you tell the agent, hey, review the documentation in this Git repository and fix the bug. An attacker has previously placed a malicious hidden instruction, maybe embedded in an invisible HTML comment within a trusted readme.md file.
And the agent just ingests that entire document, hidden payload and all.
Yes, and because AI agents are designed to follow all instructions they encounter, whether it's the user's original prompt or the context it just read it, can execute that hidden command.
The chilling scenario, detailed in the research paper, is the poisoned repository.
It is. The attacker hides a devastating bash command like rm-rf
Oh, man.
inside a seemingly benign document. If Claude Code is running in its agentic mode with executable permissions, it might just treat that command as a legitimate instruction and try to run it.
And that is terrifying because it exploits the agent's core strength, its tendency to ingest and prioritize recent context. It trusts the files because it's part of the workflow.
It completely shatters the traditional security perimeter that developers relied on.
So what's the fix?
Well, it forces a realization. The world itself is now the attack surface. And the suggested countermeasure is fascinating. It involves forcing the AI to basically debug its own instructions before acting on them.
How does that work in practice?
They recommend adopting a warning continue philosophy using new security layers. The sources call them Claude hooks. This hook scans the external data before it gets fully injected into the model's context. If it finds something suspicious, it injects a specific warning back into the context the model is about to read.
So it turns the AI into its own security guard.
In a way, yes. The model is then forced to use its own deep reasoning to decide if it should proceed. It turns the AI from a compliant tool into a slightly skeptical security layer.
This tension between security flaws and new capabilities, it brings us directly to the developer platform, where this critical week saw major structural changes and some immediate friction.
A lot of friction.
Let's start with the hard deadline that was looming. The Claude 3 Opus retirement window closed on January 5, 2026.
This was a non-negotiable end-of-life date. If you were a developer relying on that foundational Claude 3 Opus model, you had until the end of this period to transition. If you hadn't, your request would just start failing.
And while it was compulsory, this migration had a massive economic incentive. Developers had to upgrade to Claude Opus 4.5 or 4.1, the incentive, a reported 67% cost reduction.
The economics here are a powerful driver. I mean, the older Opus model was priced at $75 per million output tokens. For enterprise developers, that was just prohibitively expensive at scale. The new Opus 4.5 is priced at just $25 per million. This wasn't just a discount. This was a fundamental business disruption that essentially made any service built on the old model unprofitable overnight.
And it's not just cheaper, it's better. The technical sources show Opus 4.5 scores about 73.3% on the SW benchmark.
Yeah, compared to the original Opus 3's roughly 33%.
So you're paying less than half the price for a model that's more than twice as effective at high-level coding tasks.
It's a clear strategic move. Commoditize the previous generation while dramatically increasing the price performance of the new one. The problem is that forcing such a rapid upgrade, especially over the holidays, created immediate scaling friction when everyone came back to work.
That friction point leads us right to the post-holiday woes. Our sources documented that Claude Code was hit with post-holiday API rate limit bugs on January 2nd.
Exactly. Developers who were just starting to use their shiny, cheapo 4.5 models immediately started hitting walls. It seems that temporary holiday capacity limits reverted back to standard developer rates incorrectly.
But the bug highlights a deeper tension within the platform, right? Around complex, autonomous tasks.
It does. It comes down to those tokens again. See, developers running complex agentic requests often use the high-effort reasoning mode.
Okay. And what's the consequence of that mode when it comes to cost and rate limits?
When you set the model to high effort, you're telling it to enter an extended internal thought process to solve a hard problem. The model generates thousands of internal thinking tokens. Tokens you, the user, never see as output to form its logic.
But those internal tokens still count against your rate limit.
They still burn through your rate limit, so you're essentially paying for the model's internal struggle.
So a single complex task could eat your entire 5-hour quota in minutes.
In minutes, yes. Just because the model is engaging in deep multi-step reasoning. And developers get frustrated because the output tokens, which reflect all that thinking, are priced 5 times higher than the input tokens. The cost of deep intelligence becomes instantly visible.
This tension, it just underlined Anthropic's core focus, autonomous work. A developer reflection published December 30th confirmed it. Claude Code logged 176 updates in 2025.
That aggressive iteration, nearly 15 updates a month, solidified Claude Code as a core development platform for long-running autonomous tasks. They stabilized key features like plan mode and subagents.
And that rapid iteration enabled powerful new frameworks to take hold. I'm thinking of the Ralph Wiggum framework. It sounds like jargon, but it's crucial for understanding how developers are getting around these rate limit issues.
It's a critical example, the Ralph Wiggum framework, named after the cartoon character.
For his persistence, I assume.
For his persistence, exactly. It demonstrates the power of autonomous loops. It turns Claude Code from a tool that tries once and gives up into a persistent loop that keeps trying until it meets clear success criteria.
How does that work in the code?
The key is a programmatic control called a stop hook. When Claude tries to exit the session, saying, "I'm done," or hitting an error, the hook intercepts that signal. If the success criteria aren't met, the hook just throws everything back into the loop, forcing the model to debug itself and try again.
So instead of a developer constantly monitoring and debugging, they can give the agent a complex command like migrate all our tests from jest to betas, set a maximum number of attempts, and just walk away.
That's the definition of an autonomous workflow. And this is where the new economics of Opus 4.5 really shine. The only viable way to run these massive iterative loops is through aggressive efficiency measures like prompt caching,
Right.
which gives you up to a 90% discount on cached reads. When the agent is repeatedly reading the same code base in a Ralph Wiggum loop, the cost just plummets. Efficiency, driven by platform architecture, now defines the cost, not raw API calls.
So if we pull back and synthesize this crucial week, December 28, 2025, to January 4, 2026, we see this decisive move. AI is no longer just a friendly, helpful chat tool. It's an autonomous, regulated utility.
The Frontier Compliance Framework made safety mandatory on January 1st. At the same time, the discovery of indirect prompt injection proved that security can no longer be contained. The world itself is now the agent's attack surface.
And on the economic side, the retirement of Claude 3 Opus showed that frontier intelligence is now a commoditized utility. The competition isn't just about raw intelligence anymore. It's about having the most efficient and secure infrastructure to run that intelligence at scale.
Which brings us to a fundamental philosophical question for those of you who work in engineering and software development.
Because the human role is clearly changing. You're not necessarily writing the code anymore. You're writing the success criteria for the autonomous agent.
Your job shifts dramatically. It becomes about the clear, precise articulation of architectural intent and defining binary completion metrics for the AI. This raises a final, provocative question for you to consider as you wrap up this deep dive. What happens to the joy of engineering, that intellectual satisfaction of solving a complex bug manually, when your primary job is only the clear and precise articulation of architectural intent to a persistent self-debugging machine?